To sketch the graph of this equation, we need to find its slope using the first derivative and its concavity using the second derivative. So, the first derivative of this equation is negative 12x cubed plus 4. We need to set the equation equal to 0 and then solve for x. After solving for x, you get the critical point. The critical point would be only 0.69. Then, after taking out the second derivative, you need to, well, in this case would be negative 36x squared. You again need to set the equation equal to 0, solve for x, and in this case your inflection point would be 0. Then you have to put this in a number line. 0.69, just to have a reference. You need to find out if the slope would be positive or negative. So to do this, you need to set a number before 0, a number between 0 and 0.69, and a number between 0.69 and 1. So, in this case, we substitute with negative 1 and it gave us a positive number. So it means that the slope between whatever number before 0 and 0 would be increasing. Then, we chose a number between 0 and 0.69. And again, we got a positive number. So it means that between 0 and 0.69, slope is increasing too. Then we substitute a number between 0.69 and 1. And it gave us a negative number. So it means that between 0.69 and 1, slope would be negative. So now, we needed to do the same thing with concavity. And in this case, we substitute with numbers between whatever number before 0 and between 0 and 0.69 and 0.69 and 1, and it gave us negative in all of them. This means that whole graph would be a concave. The last step is to find the y-intercept for the critical and inflection point. You substitute each point in their corresponding formula and you get the coordinates. This is our graph critical point and this is our inflection point. And first we have a positive slope concave down until here. Then we have again positive slope concave down until here. And then we have a negative slope concave down and it goes down and it's a sad face or concave down.